Today we'll be looking at theories of logarithm. Theories of logarithms. Now, logarithm deals with numbers that can be simplified using some basic rules. And these rules are guiding the operations between numbers such as multiplication, division, powers, and also change of base. So the rules that we can apply anytime we come across this in logarithm, that is what we are going to discuss today. The first one is number or logarithm of number with the same base. Logarithm of number with the same base is going to give us 1. For example, if we have log 2 base 2, it is 1. Log 10 base 10, it is 1. So, unlike indices, if you look at logarithm here, whatever we have here is the one functioning as a number. This is a number, while what we have here is what we call the base. So a number that is read, so logarithm of number to the same base is going to give us 1. For example, if we have log 10 is going to give us 1 because this is what we call natural log. What we have here is 10, is a natural base. Now the second one is this. If we have log m raised to power p base a, this is going to give us this p that we are seeing here. We come and multiply any number that is there. That is going to be p log m base a. Then number 3 is if log s base a is equal to log y base a. If you look at it very well, you will see that the both sides of the equation, they are having the same base. Here we can remove the common logarithm. Say then s is equal to y. S is equal to y. Number 4. If log m base a is equal to s, this law tells us the relationship between logarithm and indices. Then m is equal to a raised to power s. Now let's see how we can explain it further. If we have log, or now that we're having log m base a that is equal to s, we have known that any logarithm of number to the same base is equal to 1. So I can write log a base a here. I'm using a log a base a because the base that I have here is a. So I will use the same number. So if you now look at this now, I can write log m base a equals to, looking at the second law of this second law. This law is vice versa. If this can move to this place, by the time we are simplifying something in this form, this p will move to this power. That is what we are going to apply here. Then s will move and multiply the power of a here. Then we have this one. If you now look at it very well, look at both sides of the equation. If you now remove the common logarithm, which is log a and log base a, you can see that at the end of the day we have m is equal to a raised to power s, which is the same as this. So this is how we can explain it, and you can also take it when you are solving problems. Number 5 is talking about logarithm of product. If we have log mn base a, this is logarithm of product, is equal to addition of separate logarithm. Addition of separate logarithm. This is what it's going to give us. For example, if we have log 72, maybe in base 10, it's going to give us log 10 multiplied by 7.2 base 10, which is going to give us log 10 base 10 plus log 7.2 base 10. This is how we simplify this one. Take note that log m base a multiplied by log n base a is not equal to log m plus log n base 10 plus log n base 10. We have to take note of this. It's very, very important. They are not the same. Now let's move on. The sixth one is logarithm of division. If you have log m over n base 10, it's going to give us the difference of separate logarithm. That will be log m base 10 minus log n base 10. Now let's take for example e.g. if we have log 3 over 10 base 10, log 3 over 10 base 10 is going to give us log 3 base 10 minus log 10 base 10. This is how we simplify this one. Now I want us to take this one very important, that log m base a divided by log n base a is not equal to log m base a minus log n base a. So let's take this one very, very important. It's very important when we are dealing with theory of logarithm. Now let's look at the seventh law. The seventh law deals with logarithm of number into another base. You can have log m base a to, let's say, base s. This one will give us, we want to convert from log m base a to base s. That is, we want to change its base to another base, which is s. How do we treat this one? We start with, say, log m. We are not going to put a as a base again. Now s will now be the base, divided by log. The base that you have here becomes a number, that is log a base s. We have converted it. This is how to change logarithm of a base to another base. Let's take for example, we have log 5 base 3 to base 2. If you are converting log 5 base 3 to base 2, that will give us log 5 base 2 divided by log 3 base 2. That is how to convert it. Now let's look at this one. Maybe we have log 3 base 25 and we want to convert it to maybe to base 2. This is what we do. If you look at this now, we can equally change it to base 2. Just looking at this, we say log 3 base 2 divided by log 25 base 2. This is how we do this one. Then any simplification for that I have it, we can continue from there. Then the last of the theorems is log 1 base a is going to give us 0. That is, if we have log 1 base 10, it's going to give us 0. Even our calculator, if we press log 1, it's going to give you 0. Why? Because the natural base that we have is already in base 10. So any logarithm that has to do with 1 is going to give us 0. Now we want to look at some problems that are related to theory of logarithm, how we can simplify, how we can find the value of the unknown when necessary. That is what we want to look at now. We have to simplify log root 27 divided by log 9. Solution, we have log root 27 over log 9. Now, first of all, what we do is to change this one to 1 over 2. The square, that will give us log 27 raised to the power 1 over 2. That is the expression from indices. Then divided by log 9. Now, we now change them to their index form. Talking about the 27 and the 9. You can say log 27 can be written as 3 raised to the power 3. Then multiply by half, 1 over 2. Divided by log 9 can be written as 3 raised to the power 2. Then we now have log 3 raised to the power 3 times 1 over 2 will give us 3 over 2 divided by log 3 raised to the power 2. Now, from one of the laws, second law of this logarithm says this will move to this side, this will also move to this side, the power will move. So we have 3 over 2 log 3 divided by 2 log 3. Now you can now see that the log 3 can remove log 3. So we are left with 3 over 2 divided by 2. So in this situation, since the numerator is fraction, that will be 3 over 2 times 1 over 2. So our answer is going to be 3 over 4. So this is our answer. This is how we simplify the logarithm in this form. Let's look at the second problem. Problem 2. Simplify log root 20 plus log 5 base 10 minus log square root of 5 base 10. Solution. Now we have log root 20 plus log 5 base 10 root 20 base 10 minus log root 5 base 10. Now, as you can see, this one has already combined logarithm of product and that of division. If you look at this is from logarithm of product, and everything here with this is logarithm of division. So we now treat it this way. We look at this. Since they are having the same base, so we now pick one. Log to base 10, you open a bracket of root 20 times 5. We are picking times 5 because these two are from logarithm of product. Then with this one will be logarithm of division, so divided by root 5. So this is how we are going to simplify it. Then if you now look at it, we have log base 10. 20, we can rewrite it as 2 root 5 multiplied by 5 divided by root 5. Then we can proceed by saying log base 10, which is 2 times root 5 times 5 divided by root 5. You can also say that root 5 can remove root 5. We are left with log 2 times 5 base 10. Then this will now give us log 2 times 5 give us 10 base 10. Now if you now look at this now, this has given us a number, logarithm of a number with the same base. So our answer is equal to 1 according to the rule. So this is answer. This is how we simplify logarithm of the same base. Problem 3. Simplify log 4 base 2 plus log 2 base 4 minus log 5 base 25. Solution. We have log 4 base 2 plus log 2 base 4 minus log 5 base 25. If you look at this very well, you see that their bases are different. This is base 2, this is base 4, this is base 25. We start our solution from here. We have nothing to do with this because this one is straightforward. Because if you change 4 to 2 raised to power 2, you see that the 2 will come here. Then we now have log 2 base 2. Everything here will give us 2. Now let's look at this. What we do to this is different from what we are going to do to this one. Let's analyze it first. We have log 2 base 4. We are going to change this one to base 2, which will now give us log 2. Then if you look at this one, is 4. We can say it is 2 raised to power 2. Now, this one has given us index form. Here, 2 is acting as though everything here is the base. But here, in that base, we're having an index number, where this 2 is the base. Then, this one that's acting at the power will now be multiplied. The inverse of it will multiply everything here. This base will remain. Then this power will give us log 2. This base will remain here, then multiply by the inverse of this power, which will give us 1 over 2 log 2 base 2. That is going to be 1 over 2, because log 2 base 2 is going to give us 1. Let's look at the second one before we solve the problem so that we can understand it very well. We have log 5 base 25. If you are converting this one out to base 2, you see that we have log 5. 25 can be written as 5 raised to power 2. Now here you can see that here 5 raised to power 2 is the base. Then the 2 here is the power. It will be changed to inverse. Then its inverse will now multiply everything, while the base 5 here will remain as the base. So we're having log 5 base 5 multiplied by 1 over 2. This 1 over 2 comes from the inverse of the available power here. Inverse of the power, the reciprocal of the power. So we now have 1 over 2 times log 5 base 5. Our answer will still be 1 over 2 because this one is going to give us 1. Let's go back to the question. Now let's simplify. Let's start with this one. Log 4 can be written as 2 raised to power 2 base 2 plus log 2 raised to power 2 base 2 raised to power 2. I've changed this to this based on what we have explained before, minus log 5. This 25 now cannot be written as 5 raised to power 2. Now these 2 can come here. We have 2 log 2 base 2. Now plus this one will now change to inverse. The reciprocal of the power will now multiply with that will be 1 over 2 log 2 base 2 minus 1 over 2 log 5 base 5. Now since log 2 base 2 is 1, that will be 2 times 1 plus 1 over 2 times 1 minus 1 over 2 times 1. So here we have 2 plus 1 over 2 minus 1 over 2. So I think 1 over 2 can remove 1 over 2. Our answer is going to be 2. So this is how we simplify numbers that has to do with different base. Now let's look at the equation that involves logarithm. In this problem now we have to solve for s when log s base 9 is equal to 1.5. Solution. Log s base 9 is equal to 1.5. Here we are going to apply the rules that connect logarithm and indices together. So this one is going to give us this s is equal to 9 raised to power 1.5. This is not the answer. We still need to simplify this to the lowest form. So let's continue. S equals to 9 raised to power 1.5 is 3 over 2. Then this is in indices. This is number raised with fractional power. So this is how we are going to have it. Since the fraction is positive, that will give us, this one will become the square root 9. Then everything raised to power 3. Then x will now be square root 9 is 3. Then raised to power 3, we have 3. Then x raised to power, x will now give us 3 raised to power 3 is going to give us 3 times 3 times 3. That is 27. That is the answer. So this is how to solve this simple problem in logarithm. Problem 5. In this question, we are going to solve for s. When log s base 2 plus log s base 4 plus log s base 16 is equal to 21 over 4. We can see that they are having different bases. So we are going to apply the 7th theory in the theories of logarithm, where the base will be changed to another base. But here, when we want to solve this, what we need to look at the smallest base number. Here we are having 2, which means that we are converting all the bases to base 2. Let's solve it. Solution. We have log s base 2 plus log s base 4 plus log s base 16 is equal to 21 over 4. Now, log s base 2 is okay on its own. But let's look at this one. This is 2 raised to power 2. This is 2 raised to power 4. We are changing everything to base 2. Just look at this. We have it. 4 is 2 raised to power 2 plus log s raised to power x base 16. 16 is 2 raised to power 4. You can use 4 raised to power 2. At the end of the day, we are still going to take it to 2 raised to power 4. It is better we take it to 2 raised to power 4 because we are looking at base 2 equals 21 over 4. Let's continue. Just like what we've explained earlier, this is the power. The reciprocal of this power will multiply everything here. That will give us 1 over 2 log s. These 2 will remain as a base. Plus, this is the power. 4 is the power from this base. Then the reciprocal, which is 1 over 4, will multiply everything. That is x base 2 equals to 21 over 4. Now we are good to go. What is next now? It will look at the second law, that whatever that is here will multiply this power. Whatever that is here will multiply this power. So this is what we are going to do now. Log s base 2, it is 1 that is here. So 1 is already here. 1 times 1 is 1. Now log 1 is here. 1 over 2 multiplied by that 1 is give us, s raised to power 1 over 2, then base 2. Plus, this one will also go. That will be log s raised to power 1 over 4 base 2 equals to 21 over 4. Then we now look at the law of product, that is equal to addition of separate logarithm, which means that if you look at the base, you can see that all the numbers are in the same base. So you can decide to pick log into base 2, then open a bracket that can accommodate this and this and this. That will be x multiplied by x raised to the power 1 over 2 multiplied by x raised to the power 1 over 4. 1 is here, don't forget. Close the bracket and equate it to 21 over 4. Then log, open bracket. We are going to find, look at this is indices now. Then we sum, then this is indices. We have log, this is base 2. Then we pick x, then we sum all the exponents together. That will be 1 plus 1 over 2 plus 1 over 4, close the bracket, equals 21 over 4. Then we now sum everything together. This will give us log base 2 into x raised to the power 1 plus 1 over 2 plus 1 over 4 equals 21 over 4. Then we now find the LCM of this fraction. We have log 2 x raised to the power, the LCM is 4. So here we have 4 plus 2 plus 1, close the bracket, equals 21 over 4. Then log into base 2 x raised to the power 7. The numerator is going to give us 7 over 4. 4 plus 2 plus 1, 7, equals to 21 over 4. So what is next here now is to apply the law of the theorem, that is the relationship between logarithm and indices. The base that will be here is going to take this one as its power. This implies s raised to the power 7 over 4 is equal to 2 raised to the power 21 over 4. Now, how are we going to solve for our s? We can't divide both sides by 7 over 4. It's not possible. What we do is we now go back to our law of indices. In our last video, we look at it that this is reciprocal and power multiplication. Then we now look at the inverse of the available power. It is s that we are looking for, so it is assumed that the available power is 7 over 4. So we now multiply both power by the inverse of 7 over 4. The inverse of 7 over 4 is 4 over 7. This is what we are going to use. Then it will now be x raised to the power 7 over 4 times 4 over 7 equals to 2 raised to the power 21 over 4 times 4 over 7. Because what you do to this side, you have to do to this side so that the equation can be balanced. Then you can now see that this can remove this. We are left with s equals to 4 can remove 4. Then 7 here, 1. 7 divided by 21, we are going to have 3. So we are left with 2 raised to the power 3. So therefore, our answer will now be s equals 8. 2 raised to the power 3 is equal to 8. So this is how we can deal with questions like this in a very simplest way. Don't forget to drop your comment and ask questions. There you have the opportunity to ask questions. If anything that you don't understand at all based on what we have done today, or you have another question based on our previous videos, kindly drop your comments at the comment section. I have a question, your name is this. Any question that you want to ask, we are going to answer you. Don't forget to subscribe to this channel. Share with your friends and loved ones that you know that they need of this. Make sure you share with them so that they can benefit as well. Thank you for watching.